Hello there, and today we're going to talk about coherent sources. Now, what are these coherent sources? Coherent sources, we call it for light sources, so light waves, right? So, coherent sources are those sources which give lights of same frequency, same wavelength, and same or constant phase difference. Now, let's say that coherent sources they give same wavelength, frequency, and phase difference, or constant phase difference. Now, why did I say constant or same? Now, what is phase difference basically? See, there's a wave, and you can say that it's a phase difference of 0, pi, 2 pi. It has a phase difference of pi, or 2 pi. One up, one down. It's a 2 pi, and the way we have another one, which is going through the same way, and we can say that the distance between the maximum point in the y value and from the 0, it's like 2. For this to 2, they have the same phase difference. Now another one, let's say another wave, a, a bit bigger one, it still has the same one, pi to 2 pi, but this length it's 4 now. See, it's still constant, right? They're still proportional. It's just twice this time. It's just the length just increased 2 times. It's still constant. So you can see that they have constant phase difference. So two sources having lights of same wavelength, frequency, phase difference, or constant phase difference are called as coherent sources. Now, how can they be obtained? Two coherent sources can be easily obtained through reflection or refraction. See, imagine that this is a mirror. It's a mirror. A light wave comes and it will get reflected, right? And this light, L1, it first comes from a source. Source is denoted by the letter S. It comes from this source as a form of a wave, like this. Then it gets reflected from here. See this this light wave and this wave have nothing changed, right? Reflection doesn't change anything. The intensity remains the same, the wavelength, hardly anything changes. It's just the same wave, just got refracted. And here is the S2, right? This is the second source. It has the same wave. So you can say that this is the parent source and this is the second source, but it's the same light. There's hardly any change. So you can say that these two are coherent sources. So in reflection, this reflected wave mimics the characteristics or the properties of the parent source. That's what happens. So that's one. You can obtain coherent sources from reflection or refraction. From a denser to rarer medium, we can say that its frequency still is the same, right? When it goes from rarer to denser, the frequency of the light does not change. Now, another important concept that you need to have well fixed in your mind is that two independent sources cannot be coherent. That means if you have a lamp, let me change the, say that you have a light lamp. Okay, my drawing is shit, but imagine that this is a lamp. This is a light lamp. It gives off light, right? And there's another lamp. Now this lamp is different from this lamp. It's there are two independent sources of light. Can they act as coherent sources? No, they cannot. They cannot. Why? Why is that? How is light emitted? Light is emitted when individual atoms at an excited state, they come down to ground state. And when atoms come from an excited state to ground state, what happens? They release energy in form of electromagnetic radiation. And light is also an electromagnetic wave, right? Recall it. Light is an electromagnetic wave. So light is emitted from individual atoms. So these are two different, completely different sources. They cannot be coherent. Coherent sources are when it's the same wavelength, frequency, and phase difference. But they can be two same frequency and the same wavelength, but they cannot have same or constant phase difference. They cannot have that. So two coherent sources can only be obtained from a single source. They can be obtained only from a single source, and then maybe you can use reflection. You know, the earlier example that I showed you can get reflected and it can mimic the first light. It can act as a second source at the point of reflection. So there are some conditions. So remember this it's a very important concept that independent sources cannot be coherent. Independent sources just simply cannot be coherent. Now there are conditions to obtain coherent light sources, and the first one is that the coherent sources must be from a single source. Two coherent sources can be obtained from a single source. This is that single source with the help of a device. Now what is a device? Not any kind of a sophisticated device. You can just use a mirror. A mirror will get reflected and you can get another wave with same frequency, same phase difference, and same wavelength. So that's the first condition. Two coherent sources can be obtained from a single source with the help of a device. And then second one is that coherent sources must be S1 and S2. Let's consider that S1 and S2 are coherent sources. They must give off monochromatic lights. Monochromatic lights. Now what is monochromatic light? It's just that mono means one, single, and chromatic means color. That means of the same color, or which can be also translated into the same wavelength. S1 and S2 must give off light of the same color or of a single wavelength. They cannot be of two different colors. You can't say that a source which gives off red light and another source gives blue light. No, that's not coherent. What the fuck? No. It must be of the same color. That means must be of the same frequency. It must be of the single frequency. And the third condition is that the path difference. The path difference. If you saw the last video, you will know what path difference is. The path difference is denoted by lambda, and this lambda must not be the path difference between these two lights must be small. it must not be very big. The path difference must be small so that you can create, they can be distinct. If the path difference is very big, what happens is the light gets intermixed. It almost acts as two different lights. The path difference must be small so that you can fairly just make it out. If the path difference increases, intermixing of light takes place, which leads to illumination of light. Uniform illumination. So those are the three conditions. So that's for the coherent sources. Meet you for the next topic.